Imagine a machine so large it carries entire cities' worth of goods, built from steel and weighing hundreds of thousands of tons, yet it floats effortlessly on water. Container ships are among the largest moving objects ever created by humans, and every day they cross the oceans without sinking. How is that even possible? At first glance, a container ship looks impossible to float. A massive steel giant carrying thousands of containers across the open ocean. Some of these ships are longer than 4 football fields, taller than a 20-story building when fully stacked, and can weigh well over 200,000 tons. Yet every day these giants move silently across the seas, carrying nearly everything we use, from food and clothing to cars and electronics. So how do they not sink? The answer begins with a fundamental law of physics known as buoyancy. When an object enters water, it pushes water out of the way. This displaced water pushes back with an upward force. As long as the weight of the displaced water is equal to or greater than the weight of the ship and its cargo, the ship will float. A container ship is designed to displace an enormous amount of water, creating enough upward force to support its massive weight. Although container ships are built from steel, they are not solid blocks of metal. In reality, most of the ship's volume is empty space filled with air. This hollow design dramatically reduces the ship's overall density, making it lower than that of seawater. Just like a steel bowl can float while a solid steel block sinks, the ship's shape and internal volume allow it to stay on the surface. Floating alone is not enough. Stability is equally critical. Containers cannot be loaded randomly. Sophisticated computer systems calculate the exact position of every container to keep the ship balanced from side to side and front to back. Heavier containers are placed deep within the hull, while lighter ones are stacked higher. This careful arrangement prevents dangerous tilting and helps the ship remain upright even in rough seas. To further control balance, container ships use ballast tanks, large compartments that can be filled with seawater or emptied as needed. When a ship is lightly loaded or traveling without cargo, ballast water is added to lower the ship into the water and improve stability. When cargo is loaded, ballast water is pumped out to maintain the correct balance. This system allows the ship to adapt to changing conditions during its voyage. The ship's wide hull also plays a major role in preventing capsizing. A wider hull increases water displacement and provides resistance against rolling caused by waves and strong winds. Beneath the waterline, the hull's shape is carefully engineered to reduce drag while maintaining stability, allowing the ship to move efficiently through the ocean. Safety is further enhanced by watertight compartments built into the ship's structure. The hull is divided into multiple sealed sections, so if one area is damaged due to a collision or grounding, flooding is limited to that section alone. This design prevents the entire ship from filling with water, giving the crew time to respond and often preventing the ship from sinking entirely. Modern container ships are also equipped with advanced navigation systems, weather forecasting tools, and structural monitoring technology. Captains can avoid severe storms, adjust routes in real time, and detect stress on the ship's structure before it becomes dangerous. Combined with strict international safety regulations, these technologies further reduce the risk of accidents at sea. Together, buoyancy, intelligent loading systems, ballast control, wide hull design, watertight compartments, and modern technology allow container ships to safely carry nearly 90% of global trade across the world's oceans. These floating giants are not defying physics. They are using it, proving that with the right design and engineering, even the heaviest structures on Earth can float.